Okay. So the remainders are 5 and minus 5 and 2 respectively. I want to find the remainder when fx is divided by this. Okay. Take a minute, digest the question. Tell me what to do. Anyone? Just throw me any suggestions. No polynomials. Usually they give me polynomial. Okay, I can do it by remainder theorem, factor theorem, right? Correct or not? Hey, how come this one no polynomial given? No? No idea? Shannon?
Is it you work backwards?
Yes, I work backwards.
You times together to find
I
the top.
times together. Yes, you are right. But they leave a remainder, no? They don't have a factor. You're right for the first step. But they are not factors, So after I times, I must still remember to do what?
Add in like the remainder.
Ah, yes, correct. You're right. Okay, so for my fx, I'm going to work backwards like what Shannon say. I'm going to take this times this. Then I need to plus ax plus b. Okay, can? Then after that, from here, how? I know that f of minus 1 is what? Give me a remainder of minus 5, right? Correct or not? Correct or not? So I can plug in minus 1. This is by remainder theorem. F of minus 1, this is just 0. Then minus a plus b equals to minus 5. I do the same thing. When I plug in 4 over 3, my remainder is 2. So I'm going to plug in 4 over 3. My remainder here will be 0 again. It's 4 over 3a plus b equals to remainder 2. Do you see my two equations formed already? Okay, from here I can do my polynomial, I can do my simultaneous equation. Right or not? Can you all help me continue from here? Find the value of A and of B. Simultaneous, these two equations. So you can let B stand alone. These are just linear, not quadratic. Okay, so in this case, you see that your B is already standing alone, right? I can straight away do elimination lah, if you are comfortable with it. I know you are not, right? But the B is already the same sign, is staring at you, calling out for elimination, you know. So I will just take equation 1 minus equation 2. Why, Zachary? Don't pull your hair. Or equation 2.
I forgot to add the values in the test. Oh,
Add the
mother.
values? What values?
No, in the test, the simultaneous equation, the question came out. I
Oh,
forgot about the values.
now that I go through simultaneous, you remember what you did in your exam. Oh gosh. Okay lah, 做了就算了啦. What can you do, right? Just now I got one Sec 1 girl. She's so cute, you know. No lah, not just now. She yeah, there's this girl. She told me her marks over the Zoom chat, and then she didn't fail lah. I think she got 25 out of 35. And then she was so upset. Then she was so scared. She said, "I'm so sorry to disappoint you." But that was so cute. I said, no, as long as you try your best, it's fine. Yeah. But it's all careless mistakes. Okay, yeah. Anyway, back to this one. Oh no, quoting her exact words. "I'm so sorry if I disappoint you." Okay, so I'll take equation 1 minus equation 2. So minus A plus B minus 4/3 A plus B equals to minus 5 minus 2. This is the safest way for elimination. Safest way. Sometimes I know you all do mental sum. You said B is eliminated. Why you need to write again? Okay, sometimes you do the sign wrongly, then you will be able to tell from here. So this is minus A plus B minus 4/3 A minus B. You see? Then you are very confirmed this is eliminated off. Equals to minus 7. So minus 1 minus 4/3. It's minus 7/3A equals to minus 7. Drop the negative. A equals to 7 divided by 7/3. That is a 3. All right, that's not all. You still got a B to find. Sub it back inside 1, it's easier. Minus 3 plus B equals to minus 5. B equals to minus 5 plus 3 is minus 2. That's it. Okay, Ken? The function fx is defined by this polynomial. Oh, luckily they gave us a polynomial here, unlike in question 1. So this is more straightforward, right? Given that x plus 4, it's a factor of x, fx. Zachary, what do I sub in?
Sub in any number
Huh?
that makes the equation equal to 0.
So
And
what?
once you solve into it. So
Yeah,
negative
Shannon, I
4. Negative
Shannon is
4.
helping you. Yeah, negative 4. And I will equate it to 0 in this case. This is called what theorem?
Factor theorem.
对，谢谢你 Zachary 老师. Okay, then Shannon 老师, what is the next part? What do I sub in?
Minus 3.
Equate it to
0.
0. Remainder is
Oh wait, no, 1.
1. And this is what theorem?
The remainder theorem.
That's it. Yeah. If it's a factor, it's called factor theorem. Equate to 0. If it's a remainder, it's called remainder theorem. Equate it to the remainder. That's all. Very easy one. Okay. So fx is already this. They already gave it to us. So we don't need to write let fx equals to blah, blah, blah. All right. So I just can put in minus 4 equals, just be extra careful. Don't forget about your brackets. A, don't make silly mistakes like this. Minus 4b plus 16 equated to 0. Okay? Ayo, two unknowns, simultaneous again. All right. So minus 4 times minus 4 times minus 4. If you're not very sure, press your calculator. It's a negative 64 plus, this is a positive value, 16a minus 4b plus 16 equals to 0. 16a minus 4b. I'm going a bit fast for this. Simultaneous, it's lower sec work. Minus 48 equals to 0. I shift it over. Everything I divide by 4 throughout. Okay, shouldn't have any issues for this. All right, can I give you 2 minutes, 2 quick minutes? Can you all help me do the remainder theorem portion? Just give me the equation for that. Something like what we did. Just give me the equation will do. Don't need to solve for A and B, okay? If you are fast enough, of course, that would be great. And then not correctly. The last number there is not right. And your sign is also not right. You're subbing in what? Minus 3, right? Lucky I asked you all to do. So f of minus 3, it's equals to minus 3 whole thing cube plus a. This b is minus 3x plus 16 equals to 1, right? Then this one, it gives me minus 27 plus, this is 9. So it's 9a minus 3x plus 16 equals to 1. Okay. Then, no b. Oh, sorry. Wait. X is minus 3. My God, it's minus 3b, not minus 3x. Okay, x is minus 3, not b is minus 3. All right, then after that, 9a minus 3b equals to 1 minus 16 plus 27, which gives me 9a minus 3b equals to 27 minus 16 is 11. 11 plus 1 is 12. Then I divide by 3 throughout. I get 3a minus b equals to 4. Okay, can? Then after that, this is my equation 2. Shannon, careless
I forgot about the remainders.
Oh, no wonder. No wonder I see your sign is, your numbers on the left-hand side is very close. Okay, then from here, can we skip the simultaneous part? Because that is Sec 2 and basically not the concept I'm looking for. Okay, can I just give you the answer? If after you do simultaneous, I trust you, 8 equals to A equals to 8, B equals to 20. That's all. Okay. Then part B, what are they asking for? They said express fx as a product of linear functions, factors. What does it mean? Express fx, which is a polynomial, cubic polynomial, as linear factors. What does this mean?
So factors that don't have the power, lor,
No?
right? No? Only
What are they
create
trying to ask us to do?
factorize.
Yes, very good. Well done. They're asking us to factorize. So just put a word factorize there. Remember how to factorize cubic polynomials or not? There are two different kinds. One is by the special identity. Huh? What special identity? The A cube minus B cube. A cube plus B cube. That is one. But this is obviously not the special identity, right? Because I got so many terms here, how to be A cube minus B cube. This is the normal one. So how do we find the first factor first? Isn't it given already? It's x plus 4. Correct? So I only taught you guys one method. I think I briefly spoke about the other method, but y'all didn't really like it. So how do I find the behind term?
Long division.
Very good job. Well done. Long division. Or the other method, if y'all can recall, it's finding unknowns. For this one, I got to compare coefficient. But I think y'all didn't really like this method, right? So we will go with the long division method. Help me find the quadratic there first. Okay? Definitely it's a quadratic one. If you don't get quadratic, you know you're wrong. Why? Because here, highest power is x cubed. X times what can give me x cubed? Confirm it's x squared, what? You have an x cubed, then your highest power will be x4 already. Careless, Zachary.
No.
No,
Let me.
Can or not?
Yeah, I think.
Okay, come, send me. What's the quadratic? Shannon, very good. But they said in 3 linear, Shannon, so you got to further factorize it. So you're going to do box or T method for that. Okay, Zachary, if you lazy to type, you can read out because I see Shannon's answer already.
So bracket x plus 4, close bracket, and then open bracket x plus 2, close bracket, square.
Okay, very good. Oh, so you did the factorization already. Okay, very good job. So this quadratic gives me x squared plus 4x plus 4, which I got to further factorize it because they said only in linear. This is linear quadratic, still cannot. So I got to do it by either box method, T method, whatever method you can. This gives me x plus 2, which is x plus 2 bracket square. Very well done. Excellent. Okay. So they want to find the number of real roots of the equations of this one. Okay. So this is a bit of application question. Can you see how is this equation linked to this equation here? Basically, the values are all the same, just that your powers are not the same. Correct or not? Can I rewrite this as x square cube? Indices are, you are on the
Yeah.
chapter of indices, right? X square cube, isn't it x6? I didn't change the question. I just basically simplify it in another way. Okay. Then this one will be a x square square, right? A just now we found already, like, which is so I'm just going to put it 8 ax square square, then plus b is what? 20, yeah, thank you. 20x square, then plus 16. So my x over here, it's x square actually. Okay, which I factorize in my part 2. You all just help me factorize to this part here. But I'm just going to change all this x to what?
X squared.
Yes, that's right. So this is x squared plus 4. X squared plus 2 whole thing square equals to 0. From here, do I need to go and expand it up and solve a power 6 polynomial or not? I don't know how to do that. Correct or not? Not in my syllabus. Okay, not even in Sec 4. All right, so how? I just equate x squared plus 4 equals to 0. X squared equals to minus 4. The other side, x squared plus 2 whole thing square equals to 0. X squared plus 2 equals to square root 0, which is just 0 lah, huh? X squared equals to negative 2. Is there any solution for this or not? Don't know? Press calculator. To remove the square, I will plus minus square root minus 4. Can I ever square root a -4 value?
Nope, you can't, so it's no solution.
Yeah. So no solutions here. The other side also no solutions. So is there any solution, any real roots for this entire equation? No real roots. Okay, no real roots, meaning your graph is going to lie above your x-axis or below your x-axis. But of course, this is not a quadratic graph. I'm just saying if it's a quadratic graph, it's going to lie above or below your x-axis. But x to the power 6, we don't know what is the shape of the graph. Maybe it's an air-shaped graph. We don't know what kind of graph it's going to look like. Okay? Okay, question 3a, I'm just going to verbally run through with you. It's the same thing. Find the remainder of this when it's divided by x plus 6. So same thing, I'm just going to plug in -6. I find out what is the remainder. This is by remainder theorem. Okay, very simple. I'm just going to give you the answer. If you go back, you want to try it, you can. It's just pressing calculators lah. And you realize they like to test you negative, right? Because they want to see your brackets. Students, -6 square, they'll put -36 one, then wrong already. Okay, show that x minus 4 is a factor and hence solve the equation.
Oh.
Solve, not factorize. But before getting to solving, I need to factorize. I need to do this entire whole chunk of what we just did. Okay, so how do I show? I just plug in x equals to 4. I press my calculator. I prove that it's equals to 0. Since f bracket 4 equals to 0, therefore x minus 4 is a factor. Okay, this one very easy. So I want to solve it, but before solving it, I need to factorize it. Okay, so what is the first factor I have? Or do I need to randomly sub in values to find?
No, you already have 4.
Can I use this or not? X plus 6. Cannot. That's not a factor. It leaves you a remainder, right? Of -1360. So fx equals to x minus 4, blah, 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 blah. How to do?
Long division.
Yeah, long division again. Correct or not? So I'm going to skip this part and I'm going to give you the quadratic. It gives me 3x squared minus 5x minus 2. Of course, practice, go home and practice it. Okay, then after that, can you all just do me a favor? See if you can factorize this further. Give me the 3 values of x because I want to solve it. Up to here is just factorization. Sorry, solving you need to put equals to 0.
So you get x equals to 4 and then x equals to 2 and then x equals to -1.
Very good. Shannon, you got it? Haven't. Okay, so when I do the butterfly or the butterfly, I got one student called the factorization method butterfly. You got 3x plus 1, x minus 2, like this. Okay, then this is still equals to 0. So x minus 4 equals to 0, x equals to 4. 3x plus 1 equals to 0, 3x equals to -1, x equals to -1/3. X minus 2 equals to 0, x equals to 2. That's it. Very good. Okay, so factorization will just stop at the linear, 3 linears or 1 linear, 1 quadratic. Not all the time we can factorize it to all 3 linears. Sometimes we'll just stop at the quadratic and linear, okay? Okay. Okay, this for part 1, I won't go through because it's long division. I'm very, very, very happy with all your long divisions. All right, divide this. Answer is x squared plus 4. Okay, and then partial fractions. Can you all tell me, first thing first to check for partial fractions, very important is what? The first ever thing to check in partial fractions is what? Don't need to check, just do. Is it?
Whether it's improper or not.
Very good job. Because if it's an improper fraction and you start doing your splitting and then you start to make into partial fractions, you find your unknowns. Your teacher is going to be very happy because she doesn't need to look through anything. Just give you a 0 will do. Correct or not? So don't make them happy. All right, make them work. Okay. So for partial fractions, first thing first to check, it's always whether is it proper or improper fraction. If your power is a 3, denominator is a 3 for both sides, is it proper or improper?
Improper.
Correct. Just remember about the head and the body. If you have a head that is the same size as your body, no way, right? Okay, is you can only have a head smaller than your body. That's the only time it is a proper fraction. All right. Okay. So from here, can you just help me do a quick check? This is super proper because your head is 1, your bottom is 3. Don't need to do long division. All right. By using long division, when you divide it by this, it leaves no remainder, meaning this is a factor. Okay. So this gives me 9x plus 4. Denominator, I've already done the long division in part 1. I realized that this one is the answer with no remainder. So how can I split this up? How do I split this up? Or just leave it? You all know how to split for partial fractions with a cube or not? No, right? We only learn quadratic, repeated, and linear what? Right or not? There's no such thing as cube one. Correct? So they asked me to divide by 2x plus minus 1. I realized, it's a factor because it's remainder 0. Meaning this is also the other factor. This is the quadratic. Okay? Can I further split this x squared plus 4 to 3 linears or not? Cannot. Cannot do butterfly. I keep saying butterfly. This boy she tell me, what is T method? What is box method? I don't know. My school call it butterfly. Then I learned. Then I always tell him box method. Then he don't know what is box method. Tell him T method. He also don't know what is T method. He only know butterfly. I say, okay, then it's the same thing. Okay, so how do I split this? The first one, it's a what? Linear. How to split linear? You all like to use sign language. Just an A, right? Just one alphabet. Then quadratic. How to split quadratic? Is it one time with the square, one time without the square? Is it that one?
Is it bx plus c?
Correct. Very good job. One time with the square and one time without the square is for repeated linear. Repeated linear is where your square is outside like this. Okay. Then one time with the square, one time without the square. Square stuck inside, it's called quadratic. It's bx plus c over x squared plus 4. Anyone remember if I have a denominator of x squared, is this repeated or quadratic?
Repeated.
Very good job. Okay, this is one very important one. So if I want to split this, it's a over x plus b over x squared. One time with, one time without. This is the special one. Okay, so from here, can someone give me the linear equation? Maybe Zachary? I want to make all the denominators the same. You're muted. I cannot hear you.
8 times x squared plus 4. And
Very good.
add bx plus c times 2x plus 1.
Yeah, very good job. Well done. There's one little mistake that I made over here. What is it?
Where?
What?
Where?
Where? I asked you, you asked me where.
I
There is one little mistake that I made. Not Zachary made. I made in here. Whatever he read was all correct. But I never put the brackets here. Very important. Don't think bracket not important lah. I know lah. No, it makes a whole lot of difference, no? Right? If you don't, this C will have to rainbow in only. But it's not true. It's their entire term, bx plus c. Okay? So from here, how do I find the values of A, B, C? Two methods, comparing coefficient or substituting of values. Yes. So for this kind of squares, there is no numbers for you to substitute to eliminate it one. Okay? So your only choice is here. If you don't know, then you do it by comparing. Comparing, you got to open up everything. But I think this elimination works. Okay? What is the first value for you to sub in? First value cannot anyhow sub in, no? You confirm must eliminate something because you got 3 unknowns here. Half, very good. So I eliminate this, I eliminate this. So 9 half plus 4 equals to A half square, it's 1/4 plus 4. Then the behind is just a 0. Okay, so I just use calculator lah. This is 8.5 equals to 17 over 4a. A is equals to 8.5 divided by that. A is equals to 2. Okay, anyone give me the next value to sub in?
Negative? No. -2?
-2 No, -2 whole thing square, right? It gives you +4. 4 plus 4 is still 8.
Is it just 0?
Very good. What are you trying to eliminate here? You plug in 0 because you still got 2 unknown. You cannot sweep in, sub in one value unless you want to do simultaneous, you know. You sub in 0 with a purpose of eliminating
The
B.
B.
Yes, B times 0 is 0, right? So I will sub x equals to 0. I get 0 plus 4. A, 0 plus 4. B is gone, right? Then, but you still have a C. 0 minus 1, it's -1. Okay, help me find the value of C and help me find the value of B.
Joy, C4.
Wait, let me see. Yes, correct. C4. Then you still got one more unknown. When you're left with one unknown, you sub in anything. Up to you.
Joy is B -1.
Very good job. Well done. Okay, so now we got our ABC. C it's 4, B it's -1. Shannon, you got that? Hannah? Okay, then don't just leave it as that because you have to plug it back in. So therefore, it's 2 over 2x minus 1 plus, if you are not very comfortable with -1 coming first, then C is a positive number. What we can do is we swap it around, like this. Okay, because sometimes you all get confused. Hey, do I change the sign? Do I not change the sign? Do I just leave it like this? We don't know. Then we let the positive come first. Okay, Ken, so this is partial fractions. All right. Okay, this one same. Hey, wait. Oh, this one I went through already. Yeah, okay. That's for all. So we did the entire thing of this chapter. Partial fractions is the last portion. First part, we learned about remainder factor theorem. We learned about comparing coefficient. We didn't run through, but comparing coefficient, very simple. It's just expand it up everything. Compare the x square to x square here. Compare the x to x here. Compare constant to constant here. Okay, nothing much, but you must be careful with it. The other way of finding unknowns is to do substitutions like what I did just now, to eliminate values. So there is no fixed way as to, well, I don't want to learn comparing. I just stick to substitution. Okay, substitution may not work all the time. Any brackets that has square in there, don't bother trying to eliminate it. Only work on linear. Like just now, the x squared plus 4, remember? Someone suggested, oh, can I sub in -2? Cannot, because anything square, it will become positive. Okay, Ken? What else do we have? Then factorization, long division. Long division, I'm very happy with that. Factorization and solving, correct? Find your first factor. So in both questions earlier, they did help us to find our first factor. But if they do not give it to us, they just throw you the question and say, oh, factorize this. Then you have to sub in random numbers to find your first factor. Okay. The other portion that we didn't manage to try, it's a very small part, that is the special identity, SOAP, S-O-A-P. Same sign, opposite sign, always positive. All right, that one, I wouldn't say don't come out, but hardly lah. All right, that one hardly comes out. Okay, I'm gonna go on to the next chapter, on chapter 5. I will try to go a little bit slower for this. Okay, but the whole of chapter 5 is very, very much linked to your indices. Okay, very, very much linked to your indices. All right, let me send you the notes first. Hold on. Wait, let me delete some pages. Wait a second. Okay. I will send it on the Zoom chat and then I will send a copy in our group chat also, okay? Okay. I sent in the Zoom chat and also the group chat already. Okay. Okay, come. Let me just run through this entire chapter briefly with you. Okay. For those taking NA, this chapter, you see, if you see your textbook, there is a sign there lah. So basically, if you are the students who are taking NA, they don't study this chapter. Wow, so lucky. No lah. Okay, so first portion here. These are just the summary of it. We will have to run through everything. Okay. But just look at 6.1. 6.1, nothing much. It's really just the law of indices. AM times AN, AM plus 1, AM plus N, all these 5 laws of indices, negative laws, zero indices, rational indices, which I'm not going to touch in my A-math class. Okay, indices, you're settled. This is E-math. Okay, let's take a look at 6.2. All right, introduction to logarithm. So basically, I need to know how to convert index form to logarithmic form. This is what we call an index form that we are familiar with, that we keep touching on it in indices. This is what we call a logarithmic form. All right, if you take a look at your calculator, on the right-hand side, quite on top, you will see this button log and ln. Okay, you see this button log and ln, ln. We will need this for this chapter. Okay, so how do we read this over here? It's read as log base A y. Okay, so you need to know what I'm talking about. Log base A y. Okay, I'll be reading it like this. All right, so if I say it's a log base 7 3, it's written like this. Your base, please write small at the bottom. Your 3 write same size as your log. Sometimes your 3 has a power, for example. Please show it clearly. Don't write log base 7 3 square. That looks like a 73 square to me. Worse, I have, not trying to stereotype, but boys' handwriting, wow. I know Zachary handwriting is nice lah. But I really seen boys' handwriting, my God. Okay? They just write, I don't know what they're writing. Like that, 732. Ask me to, you go and decipher yourself, which is the base, which is the power. Okay, so please be very careful with it. Yeah. All right, so I don't know if
Where do you
this
find the
helps.
button?
Oh, where do you press the button? Just
Where do
the,
you find it?
oh, okay. On your calculator, right-hand side, LOG.
Oh, okay.
And then lon is read as LN.
Oh, okay.
Okay,
Thank you.
no problem. Okay, so this is an index form. So if I tell you that 5 to the 5 is equals to, okay, no, I'll go the other way. If I tell you log base 7, 3 equals to x. Okay, log base 7, 3 equals to x. And I want you to change it to a index form, for example. It is 7 to the power of x equals to 3. Okay, so a lot of students, they get so confused with this. I tell them now, okay, maybe they can memorize. So what I did when I was younger, okay, when I was studying like you, I also found this very confusing. So I found a method to help myself remember. I tell myself it's always 132, not 123. 132. This number 132 is very special in this logarithm. How do I use this 132? 1, 7, 2, x, 3, 3. I don't know if this works. I've tried on different students, different class. Some of them just don't get it. You find your own method to find to do the conversion. Okay? Again, let's try again. Change this to index form. 1, 3, 2. Follow 1x, 2, 71, 3, 9.
Okay.
It's a standard, ma. You need base, you need power, you need answer. Okay, Ken? Likewise, if I give you this equation and I ask you to change it to a logarithmic form, it is still 132. Right? Why? This is 1, 3, 2. So if I want to change this to a log, so log 1, 3, 2. Okay, Ken? So this is my way of remembering it. I was also confused like you all. All right, so this is just first one. Okay, this 2 special property is very important. You cannot find it anywhere in your formula sheet. All right, it is nowhere to be found in your formula sheet. There is no formulas on logarithm found in your formula sheet, by the way. The whole chunk of it in your formula sheet is mostly trigonometry. Yeah, trigonometry, binomial expansion, compound interest. For AMAth, there is the quadratic formula, and then below is the data analysis. Mostly it's all Sec 4 stuff. No, Trigo is Sec 3, but year end, very end, last 2 chapter. So log AA equals to 1. Basically, log 55 equals to 1, log 10 equals to 1, log 70 equals to 1. As long as your both base and number is the same, it is equals to 1. Why? Is there a reason why or not? You help me convert to index form. 1, 3, 2. 1 it's 5. 2 it's 1. 3 is 5. Does it make sense?
Yeah.
Yeah. 5 to the power of 1 equals to 5. Correct or not? It makes sense. Okay. This is one special power property. Sorry, special power. So can you look at your calculator? Can you help me press log 8? You realize the log that you press, yeah, correct. You realize the log that you press cannot let you press the base number. You realize or not? Correct or not? How come? Then if I want to press log base 5, how? Cannot. Okay? Calculator, that LOG button doesn't allow you to do it. All right? So what is that purpose of that? Can you help me press log 10 then?
You get 1.
Yeah. What does it mean? In your calculator, It's by default log base 10. By default, that button on your calculator is log base 10.
Okay.
Okay, can? So, yeah, okay, later I'll talk about the log base 10 again. Okay, this one, another special property. This is log any base. I can put here 5,000 to 1. It will be equals to 0. Any number. Okay, this is 0 indices. Why? 1, 3, 2. Correct or not? Can we change or not? 5,000 to the power of second number is 0 equals to 1. Does it make sense?
Yes.
Yes, this is your 0 indices.
Okay.
Okay? Okay, so these are your two special powers that you have to memorize them. They will be very useful. Okay, another thing is log 10. Log base 10, it's rewrite as LG. Okay, log base 10 is written as LG. Log base E, it's written as LN, which is pronounced as lon. Okay, can? So if I ask you what is log base E equals to?
LN squared.
No, E is a constant. It's just like pi. It's just like pi is 3.14159. So E has a value by itself. So log 55 is 1. Log EE is what?
So 1.
Oh, yeah, no, 1. No? So just now I said log E, it's ln, right? This is ln. So meaning ln E, it's 1. Can you all link all this up? For a start, very confusing. This chapter is a bit confusing. Okay, Ken? So you need to know when they write LG, if you're not comfortable with seeing this short form, you can strike it off, change it to log 10. If they write you LN, not comfortable with it, you can strike it out, write it log E.
They won't like penalize you or
They won't penalize you, it's fine. Okay, both ways are okay. But if you have a log base 10, log base 5, then there is no special name, other names to it lah. All right, can Okay, let's take a look at 6.2 first. Okay, can we just quickly do A and C together? Use the 132. Okay, very simple. 1, 3, 2. Do you all get my 1, 3, 2 or not? 10, right? Okay, so you just read 1, 2, 3. That's it. It's basically the position of the numbers lah. So 3 to the power 5 equals to 2, 4, 3. But for C, be careful. My 1, 3, 2 don't work because it must always be log something equals to something. So you flip it around first, then you 1, 3, 2 it. Okay, so this is 1, 3, 2. 6, 2 is X, 3 is 7. That's it. Okay, nothing much lah. Okay, question 9. I'm not going to run through. This is just purely pressing your calculator. You see they already give you LG means it's log base 10. And the calculator is just log LG one. Although they write there LOG, but it's log base 10 by default. Okay. Question 10, I will go through with you. Okay, question 10. Let's take a look at the first one. Can you all tell me what is this value here?
1.
Yeah, correct. Log 6, log 10, log 5, log 30. This is 1. Okay, what is this value here? It's one of the special property.
Equals 0.
Yes, correct. So this part over here, it's a 0. As long as you have a 1 here, don't care what the base is. This is 0. So 249 times 0, this is also 0. Okay, what is log 10? Okay, I don't want to see a log. I change it to log 10. 10. Why is log 10 10? Yeah, 10 times 3. This is 3. So can you see the first answer? It's 1 minus 0 plus 3, which is 4. That's it. Rest assured, exams, they are not going to come out something so simple for you. Okay, Ken? Question 2. Did anyone remember what is ln E or not? Okay, if not, I will change this to log base E and then E. What is it equals to then? 1 or 0? 1, right? Log E is 1. 1 times 2/3. This entire thing is 2/3. Okay. Oh, this is a 5.5. Okay, we work on this first. Log 5.5, 5.5.
1.
Yeah, correct. Okay. Then 1 to the power of 5.5. What is it? It's still 1. 1 to the power. Ask yourself, 1 to the power of 3 is what? 1, no? 1 times 1 times 1, ma. Okay, so this is 1. So 2 over 3 times 1, 2 over 3. Okay, can. Maybe we do C and D lah. Then I'll move on to the next law already. Okay, I'm going to go a bit faster. Log 3, this is 1. 1 times 3 is 3. 5 minus 3 is 2. 2 to the power of 7. You can use your calculator to help you. This is 128. Okay, what is ln 1?
1.
Anything with a 1. Correct, 0. Right, that brings me back to anything with a 1.
Special case.
Yeah, it's the special case. It's whatever the base is, don't need to care one. Your base can be a fraction, can be a decimal, can be a
0.
Yeah, it will just be 0. So this one also 0. 0 to the power of 88 is still 0. 0 over 88, it is still 0. That's all. Okay, Ken? Not difficult, right? Okay, maybe we do E. This ln E again, it's how much?
1.
1. Very good. 20 times 1, 20. 21 minus 20. This entire thing is just a 1. Log 1 is?
0.
0. That's it. Okay. Last one. Log 7, it's a 1. 1 times 3, it's 3 square plus log 10 is a 1.
It's a 1.
16. This is 1 to the power of 4. So it's 1 still. Then after that, this is 25 square root, which is 5. That's it.
Just slow down, calm down.
I'm very excited to go on to the next portion. Okay, so this is just the two special property that they are using. Really nothing much. The difficult one is coming. Okay, so can I get y'all to do this for me as homework? Changing it to index form. I'll do the first one for y'all, okay? How do I change it to index form? 1, 3, 2. 2 to the power of 6 equals to x. Can solve for x or not? Go and press your calculator. X is equals to 64. That's all. Can?
Okay.
Okay, come. Let's move on to these laws of logarithm. I won't touch on change of base today. I'm just going to go through briefly. Product law, quotient law, power law. They are very important. This will help you solve all your different logarithmic questions. Okay, I'll start off with the easiest one. I will start off with power law first. Okay, power law, very simple. If you have a power like this power can just go to the front. That's all.
What?
Okay, I repeat. If you have a power on your number, your power can just move to the front. That is called power law.
So what do you mean by move to the front?
Like this.
Okay.
So if I have log base 5, 7 to the power of 2, I can rewrite this as 2 times log 5, 7. This is power law.
Wait, so the power becomes like in a way the coefficient of log.
Log 5, 7, yes. 2 times,
Okay.
2 times log
Okay.
5, 7.
Okay.
Okay, vice versa. If I have something like this, I can also pull it back. You can do the other way round as well. So if I tell you 3 log 3, 11, I can rewrite this as log 3, 11 cube. Also can. Okay, power law, really nothing much. It's very simple. You just have to pull the power up and down, up to you, depending on the question, not up to you. Okay, product and quotient law, it works the same. It's just like your law of indices, right? AM times AN equals to AM plus N. Then the other one, the friend, right? AM divided by AN equals to AM minus N. It works the same thing. Okay? Log AX times plus log AY, you can combine it to become log AX times Y. Okay? But if you are careful to observe with your indices, it is the opposite. It is the opposite of your indices. So that is where students start to get confused. Do you see or not? Here it's AM times AN. Combine the power, it's a plus. But nowhere, here it's a plus, you combine it by a multiplication. So you have to be very clear on your indices before you come on to this one. If not, wow, 哪一个是哪一个 blur already. Okay? The only criteria for this is just that you need to make sure that your base is exactly the same. So you don't do things like log 5, 7 plus log 6, 3. 哎呀，随便啦, log 5, 21 啦, can lah. Cannot. Your base is not the same. Unless I change this to a log 5, 3, then okay, this is log 5, 21. Okay, maybe y'all can put a example by the side for this. So likewise, for quotient law, it's the same thing. This is a minus, this is a divide. Okay, so if I have a log 5, 9, the minus log 5, 3, that gives me log 5, 9 over 3, which is log 5, 3, like this. So these are the 3 very, very, very important rules together with your 2 properties, 2 special properties. Log 5, 5 equals to 1. log 5, 1 equals to 0. All right. This change of base, I won't go through today.
Okay.
Okay. Can you all do 1B, 2B, 3B, 4B for me as homework, together with just now that solving question. I'll do 1A, 2A, 3A, 4A with you now. Okay, very simple. Basically, this is just to use that 3 laws over there. Log 12 plus log 5. LG means, if you are not comfortable with this, log base 10, 12 plus log base 10, 5. You must make sure that your base is exactly the same. And in this case, yes, it is. So that gives me, this is what? Product law, right? Knowing the name is not important, but at least you must know so that when I go through with you, when I say product law, you don't know what product law is all about. Okay, so is this a multiplication or is this a division or times or plus? Yeah, to combine them, you share the same base and then you multiply it. Okay, then just change it back to LG. That's it. Okay, they say just express it in a single logarithmic form. Don't need to evaluate it. That's all. All right, same thing. Your base is the same thing. So this is log 4, 25.6 times 2.5. Which gives me log 464. Oh, they say find the value for this case. Okay, means for part 1, I don't need to solve, right? Question 2, I will need to solve. How? I cannot press calculator, no. Think about your indices to help you. I can break this 64 into smaller forms, right? And as much as possible, I want it to be 4 to the power of something. Then I can use my power law. So 4 to the power of 3 give me 64. I can rewrite it as log 4 cubed. From here, did we learn any laws that deals with the powers? The first law that we learn is what? Power law, right? What can I do to the power 3? Do it.
Bring to the front.
Bring to right to the front. 3 log 4. Hey, 4, I know it's a 1. So 3 times 1, 3. That's it. Okay, can? Okay, question 3A, same thing. They just want us to express it in a single logarithm. Don't need to press calculator. So this is log base E28 minus log base E4. If you're not very comfortable with it, then if it's a minus, you can, how to combine? Caution law, right? You will just log base E 28 over 4, log base E 7, change it back to ln 7. If you are comfortable working with log base E, just go ahead. Okay, Ken? Question 4, find the value of this one again. Value, okay, minus log 10. Log 10 is 1, right? Plus log 10 4 plus log 10 25. What can I do to combine this part up? This gives me minus 1 plus log 10, 25 times 4, 100. How to solve log 10, 100? I can press my calculator, right? But I don't want. Because my calculator is log base 10, ne? Right or not? If it's log base 5, then no, you can't press. Okay, so this one, just now, how did we do for this log 464? What did we do? We split, right? And we make sure that it's a base that is nice to work with, right? So this one will give me log 10, 10 squared. 100 is 10 squared. Don't forget there's a minus 1. Zachary, from here, the power 2, what to do? Pull to the front, am I right? Minus 1 plus 2 log 10, 10. Log 10, 10?
1.
Yeah. So this is minus 1 plus 2, which is 1 whole. Wow, we do 1 whole chunk just to get to 1.
Okay.
Difficult? Not very lah, right? Not. This is
It's quite
basically the
simple.
gist of indices, but of course at the back there are more difficult questions. Okay, Ken? Okay, so I did the A's with you all. You all will help me do the 1A, 2B, sorry, 1B, 2B, 3B, 4B. Okay, question 5, I'll run through with you all next week in lesson. So just 6.1, question 11, the whole thing. All right, that one basically is to change from logarithmic form to index form. So we only learn a few things about logarithm, but those are very important. So if you want to use my 132, right, you make sure it's in log something equals to something. You cannot equal something equals to log. It doesn't work already. It must be this way. It cannot be this way. Okay? It must be this way. Then from here, 1, 3, 2, 7, 2 is x, 5 is 3. Okay? This is your index form. And then another 2 special, log 5, 1. Log whatever number it is, as long as here is a 1, it's a 0. This is the 2 special. Okay? Product law, quotient law, power law. Power law, just pull the power to the front. If it's in front already, you can pull it back. Product law, it is log 5, 7 plus log 5, 9 equals to log 5, 63. Okay, but make sure that your base is exactly the same first. Okay, likewise, if this is a minus, then it will be a opposite. Instead of times, you divide. Log 5, 7 over 9. Okay, Ken? No questions? Just help me try those questions out. Those are quite basics. All right. Shouldn't be too difficult for y'all lah. Okay. Remember to send it to me on Wednesday, 9 p.m. Ken? Thank you so much, Zachary and Shannon. I'll see you all next week, same time. All right. Thank you. Bye-bye.
Thank you.
Thank you.